Okay, no joke. I just recorded cubic functions without the microphone on. That is the second video that I'm redoing. It's testing my patience. Oh my goodness. Okay, I'm gonna do this again. Sometimes I tell you. Okay, you think I'd learn, right? Nope, not learning. All right, look at cubic functions. I'm really good with this board though because, well, I've done, it's been my 5th podcast for 3 lessons. Yep, brilliant. All right, cubic functions are in the form y equals ax cubed plus bx squared plus cx plus d. The 3 tells you that this is a degree 3 function, which is an odd degree. And what does odd degree tell us? That it ends in opposite directions. So like if one arm is up on the left, the other arm is down on the right. If one arm is down on the right, the other arm is up on the left. Okay, so degree 3, odd degree. Then we have our leading coefficient. Our leading coefficient tells us how it ends on the right. That has not changed, which is really nice because it's staying consistent no matter if it's degree 1, degree 2, or degree 3, right? Just putting a smiley face here because why not, right? I'm telling you, believe me? Yeah. Okay. I can't believe I'm recording this for a second time. Not the brightest bulb today, I tell you. Okay. D. Our D value is our constant because it's the number without a variable, right? And our constant hasn't changed. It's always our y-intercept. So the great thing is, doesn't matter what degree we are, still our y-intercept. Okay? So we're going to look at an example. The example we're going to look at is y equals x cubed minus 3x squared minus x plus 3. The leading coefficient of this one's going to be a positive 1. So if there's nothing there, it's a positive 1. Oh my goodness. I need to get rid of that and try again because it's horrible. Plus 1. Okay. So we know that our leading coefficient, my kindergarten writing's still here. Leading coefficient, actually I think my daughter writes nicer than me and she's in kindergarten. Okay, leading coefficient is positive. So I know this graph ends up on right. I also know that the constant equals, oh my goodness, 3. So I know my y-intercept is at 0 and 3. Okay? Now, linear functions make a line. Quadratic functions make a parabola. Cubic functions either make sideways s with a max and a min, or they make a sideways s with just a point of inflection, just curves like this. So there's a point of inflection in the middle. You don't get a max or a min. It's just a point of inflection. Okay? So this one has a max or a min. So I'm going to use my calculator and I'm going to find my maximum, doing second trace max, and then go on the left of my max and the right of my max, and I'll get my max. And then I do second trace minimum and I find the minimum because there's a max and a min. The maximum to the nearest tenth, I'm going to round it to, is negative 0.2, comma, 3.1. And the minimum is at 2.2, comma, negative 3.1. And if you can't remember how to find it on your calculator, the mins and maxes, please message me. I can help you, okay? Normally I would show it on my calculator on the smartboard, but I'm not at school, so I can't do that. Okay, sketch the graph. Sketching a graph here. 2, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay. So we can plot our y-intercept, which is at 0 and 3. We can plot our maximum, which is at negative 0.2 and 3.1, so very close to our y-intercept, like very close. I can't even draw it as close as it needs to be because of my little pen. And then our minimum's at 2.2 and negative 3.1. So somewhere down here. And we can pull other points. Remember, second trace. Second graph. We can get our table of values. So I know I have negative 1, 1 is an x-intercept, and 3. And then I just connect them. So I go up a little bit to the maximum, down, go through this x, down, go back up here. It's a very sketchy graph. I always say try and not make your graphs look sketchy. On a piece of paper or on my printed notes, it looks really nice. On here, sketchy. Okay. So let's check and see if what we had before is true. We have a y-intercept at 3, which we do. And we said we did off our equation. And we said if we have a leading coefficient, it ends up on the right, which it does. It's also going to end down on the left because we know it's an odd degree and the arrows are in opposite directions. Now, what is great about odd degree functions? Their arrows are in opposite directions. So because their arrows are in opposite directions, your domain is always going to be XER. Holy dynamite, look how neat that looks. If only my writing always looked that neat on here. Oh, I miss my writing. That's neat. Okay, the domain XER. And the range is going to be y such that y is an element of the reals because it goes on forever up and it goes on forever out. So odd degree functions, linear and cubic, both have XER, YER unless it's a word problem. Now the end behavior, if I ask for it, which I will on your assignment, you'd say down on left and up on right. Sometimes you're asked for quadrants. This is quadrant 1, 2, 3, 4. So you'd say starts in quadrant 3 on the left, ends in quadrant 1 on the right. But I'm just happy to say down on left, up on right. Okay? Now we're going to go to that example like we've done for all the other ones, and I'm going to type it. So example. Given the graph given the graphs of the following, determine the sign of the leading, look at this, it's trying to remember me, coefficient, and the constant of the equation, and now I have to write the equation out because I can't type cubics in here. Probably could, I just am not figuring it out right now. Y equals ax cubed plus bx squared plus cx plus d. Okay? A. Okay. So we are going to only need to know that I have to cross through the y-intercept of 2. Okay? Now I'm going to have the graph have a maximum before there. So we're going to go up, we're going to hit a maximum, we're going to come back down through there, we're going to hit a minimum, and then we're going to come back up and go to a max. Okay? Now, it says, given the graphs of the following, determine the signs of the leading coefficient and the constant. And the sign of the leading coefficient. Well, I know it ends up on the right. So my leading coefficient is positive. My writing was so good and now it's gone again. Coefficient is positive. What does that mean? My leading coefficient is the a value. So a is greater than 0. Then I have a y-intercept at 0 and 2. So my constant equals 2. And my constant is the d variable, so d equals 2. Okay? Then we go to B. Okay. For B, all I know is that I need to have accurate is the -3 y-intercept. And what I'm making my graph do is actually inflect through there. So you see I don't have a max or a min, I just have a point of inflection. Sometimes that happens with cubics. Okay, so leading coefficient, sign of leading coefficient, and the constant. Well, I know I have a y-intercept at 0 and -3, which means that my d value, my constant, is -3. I also end down on right so my leading coefficient is negative. A is less than 0. Alrighty? Last thing to go over. Number of X-intercepts. Okay. The number of X-intercepts, because it's an odd degree and your arrows are in opposite directions, you're for sure always going to have 1. So I'm just going to sketch 3 different ones here to prove a point. So we can have a graph that goes like this. We could have a graph that goes, touches tangent, comes down, goes back up. We could have a graph that goes right through. Okay? If we have a graph like this, we have one x-intercept. No matter what, at minimum, for degree 1 and degree 3, you're going to have one x-intercept. Because your arrows are in opposite directions, they have to cross through at some point. Whereas degree 2, the arrows are in the same direction, so they don't have to cross through. Then you could have this point of tangency where it just touches in one spot and then goes through. So this would be 2 x-intercepts. Or you could have it go all the way through. Now the maximum number of x-intercepts is equal to the degree. So because this is degree 3, at maximum I could have 3 x-intercepts. Degree 2 would have at maximum 2. Degree 1 has at maximum 1. Okay? In summary, after you're done all of this, you must complete the assignment in classroom. Wow, I'm going to type this. It's something awful. Okay, what we're going to do is we're going to complete the assignment in Google Classroom. Now you can either print it off and finish it on there, scan it and send it in, or if you don't have a printer, totally fine. You can do it on a separate sheet of paper, scan it, send it in. I need you to post it to the week number 1, March 23rd to 27th assignment. So you're going to go into that assignment, week number 1, March 23rd to 27th assignment, and you're going to hand it in there. So you're going to scan the document and you are going to hand it in there. Okay? Once you're done, you can press hand it in, you can be done. If you want to do, so that's the minimum amount of work you can do, watching these podcasts or going through the notes and then handing in your assignment. Optional for this week, you can actually go and do the assigned questions from the textbook. If you didn't pick up a textbook, there's an online version of it in Classroom that you can go click on. It'll take you to it. So you can go there and work on some homework questions. Now, those are optional, but normally in class you would have to complete them. So in order to actually understand polynomials better, the assignment is very small and minimal. If you want to understand it better, I would suggest you do those homework questions, but they are optional. Have a good day, guys.